Hey guys, welcome back to another Unreal Engine 4 tutorial. We're back within Unreal Engine 4 and I'm going to show you how to make a couple different things throughout this series here. If you haven't been watching my channel recently, I've been working on a Kitten Cannon Clone game using blueprints in Unreal Engine 4. So I'm going to walk us through on how we make that. It's going to be step by step, feature by feature kind of thing. But just to show you what we're going to work on today, we're going to work on the power meter, the thing that's going up and down, showing the power and changing color from green to red, green to red. That also gives us the ability, you can click on it and it stops. And then if we choose the angle, eventually by clicking on the cannon, it then fires. But for right now, we're going to be working on just the power meter. Slow and steady, I guess, is what we're going to do. So to start, let's go ahead and make a new project. Right now I have just the 2D game. This is what I've been showing off before, but it's just a 2D, paper 2D kind of game. So I'm just going to open up a level here. It's just going to be a blank map. And like any other game, when you want to start, you want to first create your player controller in your game mode. So let's go ahead and do that first. To start, let's go ahead and make a new folder. We'll call it Blueprints. And then we'll right-click, we'll do a Blueprint class, and we'll do player controller first. And we'll call it KC for Kitten Cannon underscore player controller. And for the purposes of our game here, what we want to have done in the player controller is we want to show the mouse cursor, we want to enable click events, and we also want to enable mouse over events. So let's compile, save that. And then we need to make a game mode class. So let's go to Blueprint, game mode, we'll call it KC underscore game mode. We'll double click in there. And by default, we'll change the player controller class to the KC underscore player controller. So we can save that. And now, in this level, we can just go into our world settings, go to game mode override, just do KC underscore game mode. And then by default, if we play, it's just going to be a blank screen. We can't see anything right now, but that's fine for right now. And just so we have it, let's go ahead and make a character class. Call it KC underscore, and we'll call it player camera, just because the way we're going to set up the player character itself is going to be a little bit different. We're going to leave this alone. We're not going to set up the camera just yet. It's not very necessary. But now we can move on to actually making that power meter we just kind of showed off. So let's first create a new folder, and we'll call it textures. I already have this power meter kind of pre-made here. So I'm just going to right-click import. And here I call it T underscore thermometer, just because that's what it looks like. But now that we have that, we're going to create a new UMG, basically a HUD element. So let's create a new folder, we'll call it UMG, and then we'll right-click. It's going to be under User Interface, Widget Blueprint. We'll call it UMG underscore Power Meter. We'll save that. Let's double-click. And this UMG, it's going to only use two different things. It's going to use an image, and then it's going to use the progress bar. So let's select our texture. And then under Image, we'll drag that under Canvas Pattern. We'll name this Power Meter Image. And then under Image, right there, we can hit this arrow, and we have a thermometer. Obviously, we have to change its location and size here, so we just drag that out so you can see it. And then under Preview Size, we're going to do Custom. We'll change this to 1200 by 1200. And we'll just move this up to the corner. That looks all well and good. So all we need to do now is grab what's called the progress bar, throw that under the canvas paddle, and we'll call this power meter. By default, its percentage is at 0, but if we make that 1, we'll see that bluish color that's kind of displayed over here. We're going to leave it at 0 though, and what we need to do is just pretty much match up its size. Whoops. Just match its size up to the actual image as best as we can. Doesn't have to be super perfect, we just want to get it as close as we can. Let's just drag it up. There we go. And again, if we change this value from 0 to maybe 0.5, we're seeing here it's getting drawn from left to right. So we want to just change that under bar fill type. We'll change that at bottom to top. So now if we do 1, it fills it up all the way. We do 0.1, it's kind of right there, and so on and so forth. Again, we're going to leave that at 0 though. But what we're going to need to do is we're going to do a new binding. So there's that bind command right here next to the percentage. We're going to create a binding. And it's asking for a float value. So let's go ahead and create one here. Let's go into variables, and then we'll call this Power Meter Value. See, it starts off as a boolean, so let's just change that to a float. We'll make that public as well. And then we can just control it, drag that out, and bam, put that in. And the other thing we're going to affect, if you remember the demonstration, is that it goes from green to red as it gets closer to 1 to 0, up and down. So we're going to go back into the graph here, actually to the designer, where it says fill color and opacity. We're going to hit a binding for that as well. So easiest thing to do, usually with colors, I find it more difficult to create a default variable over on the left panel. So I could just grab this guy and do promote to variable, and we'll call this Power Meter Color. Now let's set a default value on this boy. So let's go under Power Meter Color. Let's change the alpha to 1. Let's change the green to 1, just so we get a nice green color. So now if we go back into the designer, we can make this 1. And it's not showing the color just yet, just because we haven't done anything with the binding. But if we make this 1 and make that 0, this is the green color we're going to be getting. You want to kind of match it up as close as you can to the image that I have. So let's go back into our graph. And Power Meter Color, it's a darker green. Let's go back to the designer. We can make this maybe 5. That's closer. But again, this default value that we're messing with right here, it's not going to be affecting anything. It's really just the Power Meter Color that's going to be affecting everything once we actually create the blueprint for it. So let's go ahead and do that right now. So let's go into Blueprints. We're going to go into Blueprint class and make an actor blueprint. We'll call this BP Power Meter. Double click on that guy. By default, the first component I always add is a scene component, call it root. And now we can grab our UMG, our power meter, and then a component here under experimental is the widget one. So let's do UMG power meter, and then under widget class, we can just place our power meter. Right now the scale, it's not very much fitting how big it is, so we can go back into our UMG. Let's go back into the designer, and I think we can change this to make this bigger and we'll impact it. Let's check. No, okay. So let's make that 1200 again. The scaling it make it? No. Okay, we just gotta make this smaller. So let's compile, go back in, it's almost there. Let's make it a little bit smaller. And there we go. So now we just gotta make sure the power meter fits that same size. So let's drag it in. Almost there. There we go. And let's just make this value 0, just so it's not showing a color by default. And then here we go. Here's our power meter in place. Compile. And now what we need to do, if you remember, we saw the actual value. It said power and then 0 to 100. That was done through a text render. So let's throw a text render in there. I'm going to do power level value. Text. We need to rotate this. And let's make its world size. We'll make this about 75. Position this a little bit above the power meter itself. And now let's also drag this onto the UMG power meter just so they're parented together. Now the last thing we need to do is create a collision box, just because we want to be able to click on this and let it respond to any kind of click events. So to do that, let's go ahead and add another component. We'll do a box collision. We'll call this Power Meter Collision. Let's parent it to the Power Meter UMG. And then it doesn't have to be perfectly scaled to it, we just want to get it as close as possible. There we go. And that's all the components. That's all we really need to do. So let's affect the collision. In order for it to respond to any kind of click events, we first need to have simulate generate hit events, and then we have to set its collision to block all. And then just to play it safe, let's go to our power meter, the UMG. Let's uncheck generate overlap events and set its collision to no collision. So now what we can do, let's grab that blueprint, and then let's go ahead, right-click, add it into our scene. And right now the text you can't really see because the material requires there to be a light source in the level. So let's go ahead, let's go place actor, let's do a directional light, rotate it, and as you can see, we're seeing the text now. And if we play, nothing's happening. Obviously, we didn't put any behavior in, but we can actually see it. So that's perfect. Let's save that. Now let's add some behavior. Let's go into our event graph. What this primarily uses to animate the color and the scale is a timeline. So let's go ahead and right-click. All the way at the bottom here, we have an add timeline. Let's call this Power Meter Animation. Double-click on it. We want to use the last keyframe at autoplay, and we want to loop this guy. We want the length to be 1 second. And then the float, we want to add a float track. And we'll call this Power Meter Animation. And it's going to be a simple 0 to 1 to 0, 3-point kind of animation curve. So let's add those points. And let's just manually put in the values here, 0, 0, 0.51, then 1, 0. And then we can hit the zoom to fit and zoom to fit vertical, horizontal. Click on all our points, right click on it, make it auto, just so it's a smoother interpolation there. And now here we go. Basically this is our animation. So now we basically need to give it some values to animate. Before we can even do that, let's go to our event begin play. We need to get a reference to our variables that we created in our UMG Power Meter class, in our widget. So to do that, let's grab our UMG Power Meter, and then out of that we'll do get user widget object. Then we can cast that to our power meter, and then from here we can promote that to a variable. And we'll call this power meter reference. Now we have a reference to that widget and all its variables. So let's compile, save that. Now, both the color and the actual float meter value, they both can be pulled from this one alpha here. So let's do alert. Let's work with the actual number first. This actual output needs to go into alpha, and we actually just can put hard numbers in. We want to go to 0 to 1, and then we need to grab our power meter reference, and then we need to set the power meter value, connect that to the update, and then the return value goes into the power meter value. And since we set this to autoplay, it should just start animating for us, and it is. Now what we need to do is actually change the color so it goes from green to red. So let's do that next. Let's move some things around just so things are organized. Now let's grab another alert, but there's going to be a linear color option. Let's put this into the alpha like we did with the other alert. And then A, it's going to be a green color. B is going to be a red color. And now we can grab our power meter reference and do a set power meter color. And then we can just put the return value here into that power meter color. Last thing we need to do, let's set the saturation up for both that green and red. Perfect. So now that's plugged out. We should now see the color change from green to red and then back to green. Perfect. Now what we need to do is set that text. So to do that, let's grab the reference to our power level value text. Pulling from that, there is a set text. And then its value, we need to make a depend on that. A, it's going to read power space colon space. And then for B, if you remember and recall, the progress bar, it reads numbers from 0 to 1. So in order for our power level text to say 0 to 100, we need to multiply that by 100. So to do that, let's go ahead and grab the return value of that alert for that float right here. Let's do a multiplication. So int times float, make this 100. And then we'll do a round. And then plug that up into B. So if we compile, save, and go in, it reads the power number. So one other minor tweak that I made to this is actually changing the text's color. So to do that, let's pull from the power level value text, and we can do a set color, or set text render color. And since this is a linear color, and this requires a color structure, it's going to convert. So let's just take the return value of our alert linear color, plug into the value of that set text render color, and there we go. Let's hit compile. And now that color changes as well. So that's perfect. So now let's add that last bit of behavior where we want to click on that thermometer, that power meter, and lock in its value. So to do that, let's select our power meter collision, and then add event, collision, it's under input, mouse input, add on clicked. And then from here, we're going to take a flip-flop. Basically, each time it's clicked, it's going to toggle from A to B, and then back and forth. What we're going to do is go into our components, power meter animation. When we first click on it, we want to stop that animation. And then what we can do now is take our power meter reference. We can do a get power meter value. And we can actually create a new variable within this class. And we'll call this power meter value. We can name it the same exact thing, just because they're separate classes. Let's make this a float. Oops. Make this a float. And then make this public, just so we have it available. And then we can alt left click drag that out and set it. Let's drag that guy out. And let's also make a new Boolean variable. We'll call it B underscore power meter, or actually power value set. Change that to a Boolean. And we're going to set this guy to true. That way, because if you remember the behavior exactly, you have to click on the power thermometer and then the cannon to lock in the angle and degrees until it fires. So we want to make sure there's a check in place for that. For B, what we can do is take the power meter animation and we can do play. Depending on how you want your behavior, you can set it to play from start, but I'm just going to set it to play so that it continues where it left off. And then we could set power value set to false. And that should be it. So let's click on it. And as you can see, it filled all the way to the top. We can see that the power bar, it's not all the way correct in terms of the power meter progress bar, so let's jump that up a little bit. Save it again, and we can try again. It's 99, 100, perfect. And you can keep doing that, but obviously nothing happens past this point. But we got that basic behavior done. So that's where we're going to leave off for this one. I just want to say thanks, guys, for watching, and I'll see you next time. Hey guys, thanks for checking out that blueprint tutorial. If you haven't already, subscribe to the Devin Level Design channel. Either click on me or the subscribe button above to do so. If you like the video, make sure you actually click like, make sure you share it, comment with more suggestions, any questions, anything like that. As well as look to the right here, and you'll see more videos, more blueprint examples, more blueprint tutorials within Unreal Engine 4. And again, I really hope you enjoy the content. We're going to do everything step by step to recreate that Kitten Cannon Clone that I've been working on, just so you guys know how to do it, just so you have references, because there's a lot of cool stuff that I've learned along the way. But for now, I want to say thank you again for watching, and I'll see you next time. Bye!